students, C12 years old, primary 6, Qifa primary school. Welcome back to another lesson for physical chemistry. For this lesson of physical chemistry, we'll be continuing to learn the Maxwell-Boltzmann function. So we're going to start off with revising what we have learned for the past two lessons. So first, it is FV. So you can, the FV basically represents the PDF. So PDF is probability density function, okay? So what does FV equal to? Also take note that this is one dimensional, so there won't be here, in this part of the video, there won't be here Vx, Vy or Vz. Here, well, over here, we're going to start with what we have proven from the last lesson, whereas FV was square root a over 2 pi then times e to the power of negative av squared over 2. So over here, if you're wondering what a is, well, let's just start off with a. So a is a constant that needs to be that will be determined in the future lessons, okay? Well, over here we know that, but what we know a is m over kbt. So wondering what's m? M is it's each particle's whose mass, while Kb is the Boltzmann constant, while T is the temperature in Kelvin. So what is Kb? Although I've already told you what it represents, but it is R over Na. So R is the universal unit for ideal gas. Well, Na being the Avogadro's number is 6.02 times 10 to the power of 23. Okay, so this is the Avogadro's number. And now if you're wondering what V is, it is basically speed, the value of the velocity. Okay, so as you can see for this part, because this is one dimensional, you may think that over here, it's like for one dimensional. Let's just start out with this part where we first use the m over kbt to become m over 2 pi kbt. And then the numerator will be mv squared over 2 kbt. Then after that, what we'll have is, okay, so if this is something that just extra, but over here you can write it another way if you want, like half mv squared is equals to epsilon. So yeah, you can just use it if you want to. Like over here, you can make it become square root a over 2 pi and then e to the power. One sec. Negative a epsilon over m. Or if you want it to be simpler, you can just have it in here because that here actually has the mv squared itself. So this, we aren't going to specify on this today. Hey, although we aren't going to specify this today, it's still fine to know about it. So over here, this is one dimensional. Oh, well, if you want to know something else, is that there's going to be conditions. Hence, if you want to get this result, it's the condition. There are three conditions. and so which we have, although we have already said it we've already explained it in the past 2 lessons, but I'm just going to say it again. So it is first, space is isotropic. Second, the gravity is neglected, and then the third is that has Vx, Vy, and Vj are independent of each other, basically saying that they do not affect each other. Well, over here, although the third point may not be as important, but we're now moving from 1 dimension to 3-dimensional. So over here, before we go to that, we're going to have dp. Basically it's basically the probability. So over here, what is this? So this is dn over n. And if you're wondering what n is, it's basically the total number of particles there is. Okay? And over here, d is basically that, the d basically just represents that it is infinitesimal. Okay? So over here, it will be fv. Well, for this part over here, what we'll have is that we'll also need a dv. Okay? So, as I told you already, it's basically the infinitesimal. Then after that, we're going to have this part. Well, this part isn't really needed anymore, but I'll erase it later. So, we'll have like this. Okay? So now, we've already finished with 1-dimensional, right? Then what about 3-dimensional? So as for 3-dimensional, fv, what is it? fv is fvx, fvy, and fvz. So as you can see here, these fvx, fvy, and fvz are changing each other, but they would not, as I told you before, they are independent of each other and thus will not affect each other. So over here, for this part, as you can see, for dp, although at first it may seem like the same thing, but over here, so before that we can know what is this part. So for this part, you'll have, this will be because there's going to be 3 of them over here. Okay, so this is going to be square root m over 2 pi kbt and then bracket cube. Okay, then for the second part, it will be mv squared over 2 kbt. So you may be wondering, why is this going to be here? Although over here it shows that it is times together, why did this end up becoming like this? So apparently for this part, v is the vx, vy, and vj times together. Okay, so for this part over here, now that we've gotten this part, we'll know what dp is, right? So once again, dn over n, the total number of particles, and then after that, But the difference here is that dv is three-dimensional. So it wouldn't just be dv here over here, okay? So fv, it will not just be dv. There will be dvx, dvy, and dvz. So for this part over here, we're doing rectangular coordinates, or you can call it Cartesian coordinates. But if we're talking about how this part, we are going to use polar coordinates. So, I mean spherical coordinates, okay? I'm sorry. So spherical coordinates. So what we're going to have here is that, so for the front part, it may seem the same. Give one sec. So over here, you have dv, but over here, remember, we are going to have spherical coordinates now. So in order for it to become spherical coordinates, you have 4 pi v square. And it will become spherical coordinates and dv. Okay, alright. So now that we have gotten this for 3 dimensions, we can move on to these 2 questions, okay? So over here, for this part, we can use this formula for these 2 questions. So I'm just going to write it here. Move this pi. Okay, now just give you one quick look, and now I'll erase it. We are now going to solve these two questions. So for the first question, since we already had the formula there, we just have to find the units, these that we do not know what its values are. So for pi, although we know what pi is, we are still going to just, we normally just write 3.14, okay? No units. Well, for v, we'll be having 400 meters per second, the speed over here. Then after that, for m, if you're wondering for m, no, I would not be finding m, because that we're going to be, so over here, m over kb here is equals to molar mass over Avogadro's number over the universal constant for ideal gas over the Avogadro's number. So the Avogadro's number from both the numerator and denominator will be simplified. Thus, it will just be the molar mass over the universal constant of ideal gas. So over here for this part, the molar mass of argon is 40 grams. But because over here while calculating, we need to do physical chemistry, so we have to use the SI unit, which is 0.04 kg. Then after that, for R, the ideal gas universal constant, it is going to be 8.314 So I am not going to say the rest of it because that we aren't going to use that much. So 8.314. Then after that, what is this unit? It is joules per molecule per Kelvin. Okay. So over here for this part, now that we have gotten these parts, P is 600 Kelvin. Reminder not to put Celsius or else you'll have to convert, but we are not going to convert. Then after that, that's going to be all for A, and the PDF will be 4 times 3.14 times 400 square, after that square root (0.04) over 2 times 3.14 times 8.314 times 600. And then after that, over here, we'll have to times e to the power of negative. So once again, m over kb. Oh, whoops. So over here for this part, we'll have 0.04 times 400 square times 2 times 8.314 times 600. So over here, now that we have gotten this part, what we'll have will be (1.526). The rest I'm not going to write it out, times 10 to the power of -3. Okay, alright. So that is the first one. And now, so you can just have a quick look. Part B. So, in order to know the number of molecules, which is what we're finding, we can first see like if there's all the other variables. So let's first see the argon. It is still argon, so the molar mass is going to be the same, still 0.04 kg. Then after that, the speed is the same, 400 meters per second. Pi and r are both the same because they are constants that they are the same, that stays the same. Well, for the temperature, it is also 600 Kelvin. So for this part, it's the same. Now let's see, what's the difference? So the difference is that over here it has 2 moles of argon. So we need 2 times the PDF. Then after that, because you're finding the molecules, because you also have the number of molecules, you also have to times the Avogadro's number. Or you can just write it as like this. So either way, it's okay. So it is basically just this result times 2 times the Avogadro's number. So now let's see. Okay, now let me just calculate for a bit. And what we got is 1.526 838 times 10 to the power of 21. Okay. Alright, so now that we have finished both of these, so the first one is that we have a few variables that we had to find. The first one, pi, was just a constant, so we are just using what we normally use, which is 3.14. Then the velocity, this is the value of the velocity, basically speed, 400 meters per second. Then after that, the molar, the reason why we have to find the molar mass and the universal constant of ideal gas is because that they both had the Avogadro's number as the denominator, so they got simplified from the mass of each particle and the Boltzmann constant. Okay, so the m over kb is equal to the molar mass over the universal constant, and so we had to find this. Well, for argon it was 40 grams, but we have to use the SI unit here, so we're going to use kg. Then after that, the temperature is 600 Kelvin as shown, and also for the 600 Kelvin, and over here you cannot use Celsius because over here they are not the same thing, and we won't be converting them. So the PDF will be using this. This is the PDF, but we'll have to sub in the different values, and this is what we got. For this, the number of molecules you had to times 2 because there are 2 moles of argon, and since we're finding the number of molecules, we have to times the Avogadro's number. And that will be really all for this lesson. Last but not least, thank you for your watching.